Hello everyone, welcome back to physics class. So we are doing revision of chapter 9, force and laws of motion. In the last class we have discussed about force, its effect, type of force, balanced and unbalanced force. So if there is no unbalanced force, object cannot move. That means all the net force of, let's say if I have an object like this on my hand, if all forces acting on this object is zero, that means it is in the balanced position, it has balanced force, it is not going to move. This term unbalanced force and force is very important because that is what we are going to use in all laws of motion. Now coming to Newton's first law of motion. It was first Aristotle who said bodies at rest will remain in rest. He used the term rest, not state. Then Galileo changed it a little bit. He said no. If body is in uniform motion, it will remain in uniform motion. But he was not able to convince other scientists. Then Newton, by his experiments and theory, was able to explain that all nature or classical physics is governed by laws of motion. And what Galileo said was absolutely true. Now when I talk about, or when I say word classical physics, that means the things that we can really see, things, the forces that we can feel. Like if I drop this object, it will go down. So I know there is gravitational force acting on this object. Magnetic force you can feel, right? But these forces, or the forces at very low level, let's say electron, proton, micron, electron, proton, neutron, they changed. There, the type of forces, bonding is literally different than what we are going to study here. So that area, that region is your quantum physics. And when we go beyond this classical physics, that is at objects which are going at speed higher than speed of light, and what we have is relativistic. There we cannot use this laws of motion. There is change in their laws of physics. So this Newton's law of motion is applicable in a range, not in all part of, like not from relativistic speed to very low microscopic level. Okay. Now first law of motion. So the statement is a body or a state of body. Now when I am saying this word state, that means it can be rest or uniform motion. It want to retain a body in whatever state it is, it want to remain in that state unless you have some unbalanced force acting on it. And there's one more condition. Body should always move in straight line. This word straight line is very important because if you remember, in the last chapter we have seen that in circular motion, though speed is constant, but at each and every point, direction is changing, so the body is accelerating. So here when I am using a specific word, this uniform motion in a straight line, that means there is no change in direction. Because if there is change in direction, that signifies body is accelerating, and that means you have some external force. So no. So first thing to note down is when I am saying state of an object, that means it can be at rest or in uniform motion. And what is uniform motion? If a body travels equal distance in equal interval of time. So body is not going to change its state unless you have some external force. That means if a body is moving, it will keep on moving in straight line until you apply some unbalanced force or external force. Or if, let's say this object, this marker, if this is in my hand, it will remain at rest position. It is not going to change until I apply some external force. Okay. And this property of the body to resist these changes is known as inertia. Okay. So what is inertia? Inertia is resistance of the body to, it doesn't resist or it doesn't want to change its state. Now let's say you have two things, a ball and a stone. They have same size. Now both are at rest position. Now in which case you will feel you have to apply more force to move that body? Obviously stone. Why? Because it has more inertia. So now you can relate which property of stone is proportional to inertia. You can say because your stone is heavy, so you are not able to move it. That means inertia is proportional to mass. So this property, inertia, is proportional to mass. That means more massive the body, more difficult it is to change its state. So this first law of motion is also known as law of inertia.